video is on Unit 2, Chapter 4, Lesson number 3 on the complex number system. In your notes here, the complex numbers are represented with the letter C. Just like in our real number system, the real numbers were represented with the letter R. And of course, you had rationals and irrationals. Rationals Q, irrationals I. And then your natural, whole, and integers. Integers were Z. Whole was a W, and N was the natural numbers. So the complex number system is represented using the letter C. And to put this in perspective for you, the real number system is a part of the complex number system. So if this box represents all of the complex numbers, the real number system is inside the complex number system. The complex number system is made up of all real numbers plus the pure imaginary numbers. Okay, so in the notes here it says consider the number 5 plus 2i. Because 5 is a real number and 2i is a pure imaginary number, they are not like terms and cannot be combined. This type of expression is called a complex number. Standard form of a complex number is a plus bi, where a is the real part and the bi is the imaginary part. Now, the real part must always be named first. Always. All right, let's look at adding and subtracting complex numbers. To add or subtract, basically you're just combining like terms. It says to simplify the expression below, final answers must be in a plus bi form. So number 1 says negative 11 plus 3i plus 9 plus 2i. So we're just combining like terms. Let's go through. Because it has to be in the form a plus bi, I always like to start with the real part. So negative 11 plus 9 is a negative 2. And then for my imaginary parts, 3i plus 2i is a positive 5i. That's how you add. And yes, it is that simple. For subtraction, like on number 3, you have 7 minus 2i minus 2 plus 6i. So to do this, what I would do is just like I've shown you before, distribute that negative 1 first. Negative 1 times 2 is negative 2. Negative 1 times the 6i is a negative 6i. Then what you can do is go through and combine your like parts. So add the real parts. 7 minus 2 is 5. And then your imaginary parts, negative 2i minus 6i would be a negative 8i. Now, you can do this in the graphing calculator or the calculator. Let me show you real quick. If I take question number 2, for example, I'm going to open a parentheses, 4 plus I plus 7 minus 5i. And the calculator is going to spit out 11 minus 4i, which is the answer. 11 minus 4i. And to prove it to you, again, you'll combine your real parts. 4 plus 7 is 11. And then your imaginary parts, I plus negative 5i is a negative 4i. Number 4, again, you could either do in the graphing calculator or you could distribute your negative 1 and then combine your like terms. If you're curious, the answer there is negative 9 plus 4i. All right, moving on down to multiplying complex numbers. So the directions here, again, are going to tell us to simplify the expression. Final answers must be in a plus bi form. But before I get started on that, let's recall that I squared is equal to negative 1. Again, you have to, when you're doing this by hand, you have to remember that I squared is equal to negative 1. Yes, you can do this in the graphing calculator. However, I would like for you guys to try multiplication by hand. I have seen sample questions on the EOC where these have ended up on the non-calculator portion. So again, we just want to try to do this by hand. Distributing on number 5, 2i times 8 is 16i. And then 2i times negative 3i is going to be a negative 6i squared. And again, as soon as you see an I squared, you need to remember that that's equal to negative 1. So what is negative 6 times negative 1? Well, that's a positive 6. So this is really 16i plus 6. Now, the format is wrong because remember, it's in a plus bi form where the real number is first and then the imaginary part is second. So 6 plus 16i is the answer to number 5. Number 6 is going to be similar to that. 10 plus 2i is the answer for number 6 if you're working that. Number 7 is going to be using FOIL. Some teachers call it FOIL. We can just distribute 7 times 4 and 7 times negative I. So 28 minus 7i. And then you distribute the I times 4 is a positive 4i. And then I times negative I is a negative I squared. And again, y'all, as soon as I see I squared, I think negative 1. Now, what happens when we multiply things by negative 1? They simply just change the sign. So this negative 1 that's in front of the I squared is going to become a plus 1. So typically what I do to save myself time in a step is I just cross out the I squared and then change the sign and include the number. So for example, back up here on number 5, where you see the minus 6i squared, when I'm working this, I just put plus 6 because the I squared is equal to negative 1. The negative 1 is going to make that negative 6 a positive 6. Now we can combine, back to number 7, our like parts. Real parts first. 28 plus 1 is 29. Imaginary parts next. Negative 7i plus 4i is a negative 3i. Now when you look at question number 9, again, number 8 is just like number 7. But when you look at questions like number 9, 6 minus 2i squared, what that means is that you have got 2 of these binomials. And you're supposed to write those out twice and do just like we did on number 7. 6 times 6 is 36. 6 times negative 2i is negative 12i. Distribute the negative 2i. Negative 2i times 6 is another negative 12i. And then negative 2 times negative 2 is a positive 4i squared. And again, I squared is equal to negative 1. Negative 1 times 4 is a negative 4. So I'm just going to cross that out and put a minus 4. Now I can combine my real parts. 36 minus 4 is 32. And negative 12i and another negative 12i is a negative 24i. But again, I say to you, if you're really struggling as you're going through these, you want to make sure you understand how to use the calculator. Let me show you number 10. In the calculator, you've got 1 plus 7i times 9 plus 3i minus 4 plus 2i. And the answer here is negative 16 plus 64i. Now, I realize that it's very tempting to only use the calculator, but on the simple ones, like especially like numbers 5 and 7, I would like for you to do those out by hand. All right, let's move on forward in our notes here. Complex conjugates. 2 complex conjugates of the form a plus bi and a minus bi are called complex conjugates. The product of 2 conjugates is always a real number. Now, this is an important concept in Algebra 2. In this whole entire lesson, this whole entire chapter on quadratics, when we multiply conjugates together, it's always going to be equal to a real number, which is significant because the imaginary part goes away. When we talk about complex conjugates, only the imaginary part changes signs. So if I asked you, what's the complex conjugate of 5 minus 6i. The complex conjugate would be 5 plus 6i. We only change the sign on the imaginary part. So let me show you one of these really fast. I'm going to do number 12. Multiplying this out, we're going to distribute the 5 times 5 is 25. 5 times 4i is a positive 20i. The negative 4i is going to get distributed. Negative 4i times 5 is a negative 20i. And then negative 4i times positive 4i is a negative 16i squared. Now, here again, I squared is equal to negative 1. The negative 1 is going to make this negative 16 a plus 16. And then a positive 20i and a negative 20i are going to cancel each other out. They're going to subtract out. And what we have left is just 25 plus 16, which is equal to 41. So again, when we multiply complex conjugates, the imaginary parts go away and we're left with just the real parts. Dividing, in your notes here, it says, watch out, I cannot be in the denominator of a complex number. If the denominator is a monomial, multiply the top and the bottom by I, and then if the denominator is a binomial, multiply the top and the bottom by the conjugate. So I'm going to tell you right now, we are not doing this. We are not going to do division by hand. We are going to strictly use the graphing calculator, so watch very carefully. Number 13, I got 10 divided by 2i. I'm going to use my fraction function, 10 over 2i, and the calculator is going to tell me that's equal to negative 5i. So when it's division, you have my permission to strictly use the graphing calculator. Let me show you number 15. Again, fraction. We've got 28 minus 8i in the numerator and 4i in the denominator. And our answer is negative 2 minus 7i. And then I'm going to show you one more, number 17. We've got negative 2 being divided by 5 minus I. And our answer here says negative 5/13 minus 1/13 I. And there's your answer. Just a warning here. Notice that the two fractions have the same denominator. So sometimes you might see this written as just one fraction. You take those numerators, negative 5 minus 1, the I actually becomes part of that numerator. 5 minus I all over the 13. So there are your notes on lesson number 3 on the complex number system. And again, we will work on the assignment together.